So I think we can start, yeah. So can you project my screen on this? Yeah, perfect, thanks. Oh. So, welcome to the last session today. We will talk about the developed functional monitoring approach, which was developed in the project SaveGREEN. A short overview about the agenda for the workshop today. So I will start with an overview about the functional monitoring approach, the ideas and principles of this, then some words to the harmonized data model. You have some handouts, and it's for you to have some thoughts about what is missing in this data model. So I don't think we can solve this now at this workshop, so it's your homework to give me feedback if there are some properties are missing, some objects are missing to do this functional monitoring. Then I will talk about the whole application toolbox, which was developed in the SaveGREEN project, how we want to provide the data sets which were generated in the project, and having maybe a short discussion about what are the missing things in the data model. And then we have some words from Mořic, who did the fieldwork in Austria for us. The experience working with this application toolbox and what were the problems at the field. Within the project, we also developed a noise and light emission data logger. This will be presented by Christoph Berger. And at the end, we have to do some analysis with the data which were generated in the fieldwork. So we get the first view of the analysis results in Austria, and then we should have really a longer discussion what should be, what could be, or what are further analysis which we should do to detect really the functionality of corridors. Yeah, the aim of the functional monitor procedure is to determine migration measures and minimum habitat requirements based on the evaluation results and the analysis of ecological corridor segments which are functional or not non-functional. If we talk about the structural and functional connectivity, so the last project were more focusing on the most of the existing ecological corridor designations are more or less based on the concept of the structural connectivity. So for us, the next logical step in the SaveGREEN project was to develop this structural connectivity to the functional connectivity perspective. So in the SaveGREEN project, the monitoring concept is developed in a two-stage process. The first stage is the traditional. We use a GIS system, GIS to designate the corridors based on GIS models. Then we did a classification which is based on the landscape structure, a classification about the permeability of segments within the corridor. And the second step is then focusing really on this functional connectivity perspective. So we did a field-based collection of all required parameters, hopefully of all required parameters, which we need to evaluate the functional connectivity. And in the last presentation, we will give some first results of this functional connectivity analysis, which is done by Florian. Yeah, so the connectivity can be broken into structural connectivity and functional connectivity. And I found a nice definition about this. The structural connectivity refers to the physical relationship between landscape elements. This is traditionally modeled in GIS models, and then we designate the corridors, whereas the functional connectivity describes the degree to which landscape actually facilitate the movement and of organisms between areas of habitats. So this is the definition and the difference of the structural and functional connectivity. So we did the preparation of monitoring plans, and based on the results of the structural monitoring approach and the developed and consensus methodology of the functional monitoring, we take the decision. Each pilot area in SaveGREEN has very different landscape characteristics and also ecological characteristics, and therefore we agreed to define moderate minimum requirements for the functional monitoring. And these are these minimum requirements we defined for the target species, the red deer, wild boar, and large carnivores. For the monitoring methods, we use in the field photo traps, and we mapped tracks, other activity signs, direct species observations, and all these feature types, which I will present afterwards, which are part of this harmonized model. The quantity of the monitoring was, in minimum, the decision was to have 10 monitoring sites. In these monitoring sites, we have one-to-many camera traps. In minimum, there should be observation of one over and one underpass in the pilot area. In minimum, we decided to detect or to monitor 3 corridor sites. And the results of the structural monitoring of this GIS model should be considered by the selection of the monitoring sites. The functional monitoring approaches, for which species it is possible to migrate through the corridor, which was designated by the structural monitoring approach, and what are the reasons why, for example, in this case, the bear is not possible to cross this corridor, this section, which is in orange. And I think there could be many reasons for this. One could be, for example, noise. One could be also a light emission. It can be land use, and it can be the structure of the landscape, missing habitats, missing landscape elements, and so on. And therefore, we developed this data logger to detect light and noise emissions. And as I mentioned before, for the location of the monitoring sites, we considered the GIS model, and we select sites in corridor segments where we think that there is a good permeability, and corridor segments where we think the landscape structure is not as fine as in these green parts, and we have less permeability. And in these monitoring sites, we established the data logger for noise and light, and also the camera traps. Yes. To get a more holistic overview about the whole corridor, we did this field work, and we did the track monitoring inside the whole corridor. And this was done by the Cookies Field app. It's an open source mobile client app. And we have a second application which is under development, the Roadkill app, which is a direct implementation in the Android system. And these 2 applications are used for the field work to do this, to do the field work and to digitize all the mappings inside the corridor. And these are then harmonized in this, I call it harmonized data model, and then published into the database, and from there provided by web services to the website. So the core of this functional monitoring approach, I think, is, and that's really a large benefit, is this harmonized generic data model. Yeah? This generic data model defines the essential objects, which are called feature types in the GIS domain, and their properties that must be mapped within the framework of the functional monitoring approach. It defines the model semantic. So you have this awful UML diagram with this lot of boxes. And the fine thing is, so we can discuss this, and this UML diagram was discussed with all the experts, and we agreed these are the most important objects and their properties. And the fine thing is, you can directly derive from this UML diagram the logical and physical data models, so directly the database schema. Yeah? So everybody who uses this UML diagram have then the guarantee that in each database you have really the same physical data structure inside. One benefit also is this generic model can be extended, so if you need other objects or additional properties, it's very easy to extend it, but it doesn't break the physical model in the database. So you can, that's a great benefit, because you can very easily then integrate data from other projects using this generic data model. Yeah, as I mentioned, the same physical data schema is always created independently of the database system, so it makes not really any difference if it's an Oracle, it's a PostGIS database. And yeah, it's very easy. It's easy to integrate data from other projects into this database structure. There's a tool, it's called Hail Studio. There you can do the mapping, and then you can import the data into this data store. The greatest benefit is that these data sets, which use the harmonized model, are interoperable and can really be easy used and extended in further projects. Yeah, so this awful UML diagram, and what is mapped? Yeah, so for each object we map in the field, we have the information in which pilot area is it and to which data set the relationship to the data set, it's the green box, and we have the information who was the mapper of the object and what was the mapping campaign. In this mapping campaign, and for the mapper we have then additional information. The orange boxes are the objects which we are mapping in the field, and these are this 1, 2, 3, 4, 5, 10 objects, and these are related, and these are these lines. These are directly related to the mapper, to the pilot area, to the data set, and to the mapping campaign. So that's the general overview about this data model. Yeah, time is running. The workshop was originally planned for, I think, 3 hours, so we have to rush up, but to get the first idea, yeah, for example, for the overpass. Yeah. For the overpass, this is, we call this feature type, and we have here the feature properties, and these are all the properties which are mapped in the field. So we have a photo from both entrance area, we have a photo on the overpass, we have a photo of the surrounding of the overpass, we have the land cover which is on the overpass, we have the measurements width and length, you have the possibility to add some comments, and the geometry is a point geometry, which is the centroid point of this overpass. And this was then implemented in the QGIS field. And you are directly able to use this on your handy in the field. Yeah. Yeah, these are the photo on the overpass, and this is the photo of the surrounding, for example. Yeah, for the underpass, we have nearly the same feature properties. We have this photo documentation, we have the land cover, we have the width, length, and height. We have a comment, and we have the openness index. For the feature type underpass. Yeah, and this is the representation. If you open the monitoring result in your QGIS GIS client, you have these formulas where you can see the general attributes, and you have also the photos of the photo documentation of this underpass. Yeah. In this case, the mapper didn't map the surrounding of the underpass. Yeah, and we have this also for point landscape elements, also a photo documentation and the land cover type, and some comment. The same we have for linear landscape elements, but it was not used in any pilot area from the data which we have done the data integration until now. Yeah, then we have one general class, other spatial comments. Yeah, if something is missing in our feature types of this general model, we have this general feature type, other spatial comments, where you can do a photo, you can make a comment, and the spatial relation or the spatial data type is also a point. Yeah, for example, Mořic use it to map a feeding place of Caprelus, I think. Yeah. It was a feeding place. Yeah. Okay. So yeah, one of the most important feature types is the barrier, which has really a lot of attributes. So always, if you see this CL underscore, it's a code list. So we have a large, also on the hard copies, a larger hard copy about all the code lists which are used in the data model. Yeah, and for the barrier, we have the material, we have is there a presence of mitigation, we have the height measurement, the width, is it permeability or not? So a classification, we have the documentation of the photo of the barrier, of the surrounding, a surrounding description, a comment, and the purpose of the barrier. Yeah.
By barrier, is it a fence or is it the road as well without fencing?
Yeah, we have there's this code list barrier type, yeah, and there is a list of barriers, yeah, which it's a fence, for example, or let's have a look on the code list. Yeah. And yeah, you know, code lists are always not complete, so this code list can be extended. Yeah, so if you use, you need additional. No, that's not the code list. There are the code lists. Yeah. Building, yeah. And these code lists are not closed, so they are open. Normally, you should handle these code lists in a so-called code list registry. Yeah? So it's available in the web, and if you need additional types, you can register these additional types in the registry. Yeah? So, yeah, one of the most important feature types, the tracks, yeah, and there we have the species, the number of individuals, the degree of validity, because it's always hard to really say, okay, it's to classify the track. We have a photo from the above footprint, from the length, width. We have a photo of the course of the track, the step length, the direction of movement, and one field for the comments. So it looks like this, and yeah, in all pilot areas, never were used the length, the width, the length of the hint path, the width of the hint path. So we have some properties which are not really used in the field, and we should think about this if we don't delete these feature properties because they are not really used in the field. Can you mention some of them? Yeah, the length of the front path. Yeah, it was never used. Yeah, so you have a photo, it's fine. You have the classification of which animal. Yeah, but this feature properties, the length, the width, the length of the hint path, the width of the hint path, the step lengths. Yeah. Sometimes it's possible Yeah, it is.
Really wonderful.
Yeah.
But it might work in the winter conditions where you have a very clear track.
Yeah.
Not in the summer.
Yeah, for those who are not so familiar with these UML diagrams, in some properties we have 0 to 0, or where we have not this bracket 0 to star. 0 to star means you can map to use this property one to many times. Yeah. If there's nothing behind, yeah, it's a mandatory attribute. Yeah. And these mandatory attributes are very critical, because if they are not available in the dataset, I have not the possibility to integrate it in the database, because then the database import fails, yeah, which guarantees high quality of the data which you import in the database. But yeah, it makes a lot of work to finalize the datasets which we get from our partners, because I have to add these attributes, and makes a lot of work. Yeah. Yeah, and we have a direct species observation, feature type, also species, number of species, the degree of validity, photo, which is not mandatory, and you can use a comment for this direct species observation. I think this is the last one, other activity signs, and there we have also a code list. In this example, it was a rest place of Cabrelos, and you have also the possibility, number of individuals, a photo from the surrounding, and to add the comment. Yeah. So this was really hardly used by Mořic. Yeah. He had a lot of other activity sign comments. Yeah. So I think it's really a usable or a nice feature type, which is really hardly worked or hardly used in the fieldwork. Yeah. And then we have roadkill. We had in all our pilot areas, we had only one roadkill feature. Yeah. And it was this one, I think it was clearly identifiable, and this was hair roadkill. Yeah. No. No, we are happy if we have not so many roadkills. Yeah. Okay, I think, yeah. And at the end of the presentation, I will ask you if you have a first idea if there's something missing, yeah. And if you have some time to study these diagrams, please send me email if really some features are missing, or some feature types or feature properties are missing. Yeah. So this harmonized generic data model is really great, because you are not only transferring the data set, but you are also transferring the whole database schema. Yeah. So if you do this transfer, which is one line, yeah, you have only to write one line of code, and the whole database can be extracted and imported in the other database, yeah, without any loss, and you get the whole database schema from one database in the other database. Yeah. Yeah, some results from the monitoring. So we have this monitoring sites. In the monitoring site, we have some monitoring devices. From Austria, we have 2 interactive maps available from both monitoring sites. So this is the overview. So this was the selection of the monitoring sites, and inside these monitoring sites, we placed our devices. So the monitoring devices, which are in these red dots. Yeah, the general procedure is the field worker works with this QGIS application. So we provide a QGIS field project, more or less. Yeah. You can copy it on your handy, and then you are ready to go in the field and to work and to map your objects. We get then these field objects back, so they are stored in the SaveGREEN data store, and then I do transformation in this Hail Studio, generate the so-called GML file, which can then directly import in the PostGIS database, and can be also directly with one line exported. So that's the nice in this GML. And then I generate some views, and we publish this data using the OGC server, the Geo server as OGC web services. Yeah, and then we register this, or we generate maps using the map store, and the central point of the central point to access the data is the so-called data catalog. So for each pilot area, we have registered the results in this data catalog, and yeah, we'll then show how you can access the data sets we have generated within the SaveGREEN project. That's the general system overview about the whole application toolbox. So on the left side, we have this roadkill application, the cookies field. You map with these applications, you do your field work with these applications, then they are transferred to the SaveGREEN data store. We did the database integration, then it's stored in the central data store, and then we published it using this OGC web service technologies. And there's also the Geo network, which is the data catalog. And from there, you can access the dataset in a website, in common GIS clients like QGIS or in the Esri world. Or you can use only the web browser using these interactive maps, which we provide also as the map store. Okay, and then the nice thing on all this, on the application toolbox is we use open source software, so it's free available, and if you need this or you want to use the application toolbox in one of the kind of future projects, you have not really any license costs, and I'm very happy to have Christoph Berger from Special Focus on my side who supported me. Yeah? They will also provide this whole application toolbox or the components which you need for work or to establish this functional monitoring approach for a project as software as a service. So you can order the PostGIS database, the Geo server, the Geo network, and all these components. And you can focus on your thematic work. Yeah? You have not to configure this server, architect the server, so you can order this, and on the next day you have all the components available in the internet. Yeah. So how will we provide the dataset? The central point to access the data are the SaveGREEN data store. And for example, for the Kubernauserwald, you have then there these downloads and links. And first of all, we provide the whole dataset of the pilot area as a so-called geo package. Inside the geo package are all mapped objects and also the photos. Yeah? And we provide also a QGIS project file. So if you download it and open it in the QGIS, you have all the data available and also the formulas. So you have really easy access to all results of the field work and data sets. Yeah, it's some expressions. For the camera traps, you know, I think it was about 100,000 photos we made in our monitoring sites. Yeah? And Mořic did a selection only of photos where are animals on it, did a classification of this. Yeah? And also the images of these photo traps are available in a photo store, which is available in a web. So you have really access to all the images which was done in the fieldwork. And we have also the second link is the documentation of the placement of the wildlife, of the camera traps. So this is in the QGIS. We provide also for people who have not a QGIS installed on the computer, we provide these interactive maps. So you only need a browser. This is the result of the monitoring in the Kubernauserwald. There you have everything which was mapped in the field in this interactive map, and you can click the single feature and get the information and also the images will be available. It's similar to the QGIS project, which you have offline, you have also a web access to all the results of the fieldwork. And for people who have only interest on some feature types, for example, you need the tracks from Kobernauerwald or you need the traps from the other pilot area, we provide also a very common format, the ESRI shapefile, only for tracks of a pilot area. Yeah. So you have not to download all the feature types, you have also access only to the tracks or only to the barriers or only to the over and underpasses. Yeah. So you can download this and then you have this representation, you have also the links to the different photos which are available for the object. Yeah. For me, it's very important because we generate a lot of data, and I think there's a great lake on data which are available for future projects. So I hope that these data sets will be used for further analysis, and we will have a short overview what has Florian done, and at the end of the workshop, first analysis results, but I hope that all the data which we have generated in the SaveGREEN project are also used in other projects and for master thesis, for other scientific projects. So for me, it's very important to publish all this data, to publish it in different formats, so to make it really easy accessible for GIS profis and also for people who have not so much experience with GIS. Okay, that's it from my side. Time is running. So my question, if it was really a fast track, but have you any comments to the harmonized data model? Are there any features missing? Or you know, I think you will need some time to study this awful UML diagrams, but I would be happy if we get some feedback. The harmonized data model and all these things will be published on different platforms and will be made available. Also the QGIS field project and things that you can really directly work with this application toolbox.
Okay, Nicolas from France, French Biodiversity Agency. Thank you for your presentation. I was wondering if you consider integrating data on GPS monitoring on specific individuals, you know,
okay.
in your database. Would it be possible, or?
If you have GPS tracking from animals, yeah. So do we have a feature type for this? Not really, yeah. Yeah, thanks for this comment, yeah. But in our project, the decision was not to use GPS tracks because it's too expensive, yeah. But this is really one feature type which is missing in the model at the moment, yeah. But the nice thing is it's extensible. So if you know how to model GML, yeah. But we can, for the final data model, we can have a first draft also of a feature type to build up GPS tracks from animals, which would be really, it's really missing at the moment at the harmonized model. Yeah. Thanks for this comment. Yeah.
Do we have a solution for the sensitive data?
Yeah, we had a lot of discussions, yeah, because we had these discussions about can we really publish the photos of the camera traps if there are some sensitive species. Yeah. We have some, I think we have some photos also in Austria where we discussed should we publish this species because it's critical for agriculture and farmers. Yeah. But we had the decision in Austria, we want to publish the data as they are, yeah, because yeah, there's definitely some reasons where it's wise not to publish this data, but this is also, that's in the responsibility of the project partner. If the project partner says, okay, we don't publish the photos, yeah, and we have some pilot areas where no camera trap photos are published, it's okay for us. Yeah. In Austria, we had that decision, we publish all the data. Yeah. But it's not a thank you, from the project partner. Yeah. So we don't. Yeah, yeah.
Roland, thank you very much for your presentation. Back to the question about the monitoring of the GPS tracks of the animals. This is very, very important. Thank you very much this question, because we can help you to identify exactly the ecological connectivity, ecological corridors of exact species. For brown bear, large carnivores is very, very important, and the ungulate species, which are real ecological corridor. And other question that is very, very important things of the SaveGREEN project that we talk about, yes, top secret camera traps and tracks analysis. So in Hungary, this is very important that each possibility is the hunters kill the large carnivores. So it's very bad situation, not in Hungary, but in several Eastern European countries, Eastern and Middle European countries. So it's very, very protected data sets. We cannot insert the open data sets. But another example, as a freshwater biologist, I said that this was a typical problem with the water framework directed monitoring capacities, which we need to integrate it to monitoring assessment in aquatic habitat structure. And the water framework directive monitoring give very, very important information to the water directories. And after that, when they understand the background of the informations, can manage it. Previously, that no, this is a European community, idiotic, never. We use 50 years old monitoring methods, it will be good in the future. No, they can see that what happened realistic in the, for example, in the Hungarian water drainage systems, they can start to manage it, because they say that it could be help the maintenance practices and so on. And I hope that this project and the other future those projects which connected the different type of habitat structure, the different monitoring protocols of European countries, and the different mention of the peoples could be connected, that this is the future, because the animals cannot understand what is the border between two or several countries. They moved. And when we would like to protect, for example, the large carnivores, but in my view, for example, the noble crayfish population, for example, in the Carpathians, 100% that we need to start cross-border projects. Yeah. And these methods are the first steps to understand the parallel similarities or differences between the data sets. Thank you very much, Roland.
Thank you. So, where is Mořic? Ah. So now it's the part of Mořic to tell us what was the problems in establishing the field work. We had a lot of problems in Austria, especially with ground owners. So we had not the possibility to establish all monitoring sites because we didn't get any permission. Yeah. It was awful for the project because it was very important points. We will also see this in the analysis. So some really important points we didn't get the permission to do the monitoring. But Mořic, some words to your experience working with the Application Toolbox in the field. Yeah.
Good afternoon to everyone. I would like to very shortly inform you about the field work which was done in the two pilot areas in Austria. As was mentioned, we choose two approaches. One was based on the camera trapping or camera monitoring, and another was based on the tracks monitoring. The first one is quite hard because you have to put much more energy for communication, especially with the landowners and the hunters. Sometimes also the hunters know very well where to put the camera traps to obtain the relatively relevant data. But I would like to emphasize that the communication with the hunters and landowners have to be for all monitoring persistent. Yeah, and for the field track mapping, I would like to say that you have to carefully consider when you will be there in the field, because I strongly recommend that for field monitoring you have to decide visit the localities during the winter times or the spring times, because you have much more high probability that you can obtain the data also from the protected species. But comparing the summer seasons, a lot of soil are totally dried or are maintained by farmers, what caused many problems with tracking, basically. Yeah, and my last words, it's about the disadvantages, maybe for future improvements for the Q app. Some operations taking much more time than I expected, so you have to be very patient when you did such a kind of work in the field. Yeah, that's maybe all from my side, and maybe if you have any question, we can discuss later.
Thank you, Mořic. Thank you for the great work you have done in the field. It was really a lot of days where you have inside the corridors. And thanks for your great job you have done in the project. One really nice output of the SaveGREEN project are this developed noise and light data logger. We did a research, and these devices are very expensive. So the idea was to develop an open source, and these boxes the code is open source, so you can, it's based on cheap components, Android, and you are able to build up these boxes for yourself, but Christoph will present this data logger, also show you some results and give you some overview about the technical specification of these boxes, and I hope these boxes will be used. We have some boxes available here, and if you are interested, we have also this table before I think it's the blue room, the blue session room, and we will be available tomorrow also if you want to have a look for this interactive maps or how really this data integration procedure works. We will be available tomorrow. And also Christoph will be there, and if you are interested in these sensor boxes, take the chance tomorrow to get some information and how this box is working.
Okay, thank you for the introduction. So what I'm going to tell you is a bit more about these sensors. So the idea was to find out if there are potential disturbances along the corridors, and what this could be, what could be the reason for that. So therefore we built these low-cost light and noise sensors. I mean, it looks like a prototype, and it is only a prototype, but I mean, for a first idea, I think you can get the idea what it could look like. This one is already somehow battle proven. So this has been in the field for a couple of months already. I mean, you see how dirty it is and how the plastic is already bleached, but still it does some good work. On this slide you can see how it looks in practice. So we are here on one of these green bridges in Austria. where one of these sensors is mounted. On the right side, you see one in combination with the camera traps also. So we always have this sites where it's combined, camera traps and these noise and light sensors. Usually we put a few of them along the corridor, so to have one on the edge, another one in the center. So let's look at the schematics. So how this one of these measuring devices looks like. So we have this pillar in the ground. We have wildlife cameras, and then on top we have these two boxes. And you might wonder why there are two boxes to measure that. And the idea was to separate the measuring aspect from the storage and the energy, or for the battery. So what you can also see here is it's connected. In the lower part we have the batteries and we have the storage, the SD card, and in the top we have all the sensors for noise and light and the processor. So those are fixed on these pillars, and then they run for a couple of weeks or months in the field and record data. And as soon as the batteries run out, somebody has to go there, replace the batteries, replace the SD card, and then continue measuring. So the idea is to just disconnect these two, go back home with the battery box, and connect a new battery box, and the sensors will always stay the same and record consistent data. This is more technical details about these two boxes. So on top we have the sensor box. On the top of the sensor box we have this light sensor. The light sensor is very sensitive. So we can measure light pollution between 0.001 up to 1000 lux. And then on each side of this box, we have two noise sensors. And there we measure values between 30 and approximately 80 decibels. Additionally, in this measurement box, we have the Arduino, the main processor where also the firmware runs, and we have the RTC, the real-time clock. We need the real-time clock on the one hand to record also the timestamp with each measurement, and the real-time clock also gives the impulse when the measurement has to be done. So we are not continuously monitoring, but we are recording data only every 30 seconds. So twice every minute we record data. This is also for the power consumption aspect, so that we can run with only these 4 tiny batteries. We can run for 2 or 3 months in the field, depending on like weather condition. I mean, in winter, batteries run out more quickly than in summer, for example. But roughly 2 to 3 months, we can continuously record data with these 4 batteries that are placed in the battery box. So we have these 4 lithium-ion batteries. We have an SD card inside with the card reader. And then one other important aspect of the whole thing is the safety measures. I mean, you can imagine with these lithium-ion batteries somewhere in the field that could be a bit dangerous. So what we did is we included also some fuses in, so if something happens that it doesn't like explode and start a wildfire. That would be not ideal. And then also we need some electronics to deal with the discharge, because these lithium ion batteries are quite sensitive to discharging. So we have to tell them to stop discharging when they reach some certain battery level. Initially, the idea was to connect something like a external power pack, what you could use for your phone. But the problem there is that the sensors use so little energy that the power bank would not turn on. So that's why we really need to use these pure lithium-ion batteries. So like without any electronics or so. That's why we had to build that ourselves. We had to include the fuse to make sure that nothing happens there, and we have to protect the batteries as well. That brings me to some potential future improvements, because some of you might wonder why we didn't include some 4G module to get the data like in real time instead of going there every 2 or 3 months. That's a good point, and we want to tackle that maybe in a follow-up project. So we want to build a sensor network, include some LoRaWAN chips into the individual sensors, and then have some base station with a 4G module that then collects the data from the individual sensors along the track and submit that in more or less real time to some server module. And then, as I mentioned earlier, and you see that when you look at the devices, they are quite basic and primitive. So what would be a future improvement is, of course, to have some customized cases that are more appropriate for the situation. And the idea would be to really do some 3D printing and design some more appropriate cases for that. The production could also be improved. I mean, I can show it to you later on or tomorrow at our stand. Here is a lot of manual work involved. So there are dozens of cables that have to be soldered together. And in the future, of course, if we go for a bigger number of sensors, we would like to produce some optimized circuit boards and then just connect the sensors instead of like having our students do all the soldering. And then another aspect would, of course, be to include more sensors. Depending on the actual requirements of the projects, we could think about, for example, including temperature and humidity sensors. We could maybe also have some soil moisture sensors, precipitation and wind sensors, and maybe also measure air quality along the roads. That would be something as a future improvement. But maybe you have some more ideas, and depending on your projects, there might also be some other requirements that we didn't think about till now. And let me conclude with a screenshot of the recorded data that we collected with these sensors. You might not be able to recognize it, but we have two graphs. On the top, we see the light measurements, and on the bottom we have the noise measurements. The light measurements, there's only one sensor, but with the noise, we always have this left and right sensors, so that's why we have these two different colors in the graph. And you can maybe not recognize it, but you can see some trends. And these trends are obviously some day, night time, different noise levels along these roads. But there are also some outliers, which would be interesting to analyze where they come from and what happens there. For example, also in the light part, where we have a very low light situation in this first part of the graph, and then we have some outliers for a few minutes or maybe half an hour or so, where we recorded some significantly higher light levels. That would be also something where we could then maybe look at the camera traps and see what happened there. As I said, we have these with these visualizations. We have some maps and dynamic graphs. So I can show you later or tomorrow at our stand where we can have a more detailed look into the data that we recorded. So thank you very much, and I'm open for any questions.
Hello, I'm Piret, I'm from Estonia, and I was wondering if you chose the sound sensors, did you consider the hearing differences of different animals that would be affected?
That's a very interesting point. So the microphones that we are using are actually not measuring the decibels that we are displaying in the graph. So they are recording some raw noise levels. And we then did some calibration using some professional sound meter, and then calibrated it on the decibel scale for humans. But we have the raw values, and if you have some different calibration data, we can of course just convert it into other scales as well.
So you have raw data, so it's okay.
Yes.
I don't know what. Is it okay? And about those batteries, if they run out, do they send a signal that you need to go and change, or you just have to check?
Yes, yeah. I mean, there's no information, there's no connectivity to any server or backend or anything. I mean, there is no backend, in fact, so they are not sending any information. So that's a bit risky, and therefore we usually try to go into this lower interval and replace them every 2 months, even if they would maybe go for another month. And that's also why we chose this two-step approach, to have these battery packs that you can easily replace, because it takes some time to charge the batteries, and then you just go out, replace the whole package, and you're good to go again.
First, I need to be a lawyer. This development which you start to protect, you need to protect in the license, because a new Elon Musk is coming and it will be stolen 100%, earn a lot of money, not you, but another company leaders. First, thank you very much. It's very interesting presentations. I have thousands of questions. First, I would like to follow the noise problem of which was drive the colleagues. That a lot of species, for example, amphibians, can be adapt the basic noise of the surrounding landscape. We see the differences, the communication, for example, Natura 2000 species, bombina, in those areas which was well urbanized. So the landscape absolutely deeper as in those areas where was absolutely natural habitat structure. So if it's possible that two populations can be not connected together, because they can the noise can deeper and pressure the communication between the two populations, and they cannot understand because one population think higher as the other one. And it is interesting to see that what is the basic noise of your landscape. This could be calibrated with the sensors, because you heard the noise, but it could be the noise of the grass, of the leaves, of the forest. So it's quite interesting, and the animals need to adapt to this noise. And first, one interesting test you need to first start. In Hungary, we see that those overpasses and underpasses use not those animals which communicated with normal zones, in our view, which are not protected fence or forested protected region in the overpasses. So this noise and sounds sensors could be make a measuring process in those overpasses which are not protected with fence or with bushes lines parallel with the and zones, and those which are open. The noise and noise landscape and the light landscape is absolutely different. And the other one, in my view, that you need to protect inside to these methods one sensors which measure the flexibility of the overpasses, because several species, for example, large ungulates, the ungulate system, the head system is so sensitive that doesn't prefer those overpasses which move together with the road system. For example, in Hungary, doesn't prefer the engineers the overpasses in high-speed river network, because there is absolutely inflexible, because the river lines, these dams which created from stones and riprapes, is need to be very flexible, and these concreted blocks, which are the basic settlements of basic type of the overpasses, drive the moving process of the zone. So it's quite interesting that when you created these sensors, you can measure that 10-meter deep ground or soil, 20-meter deep soil, or 1-meter deep soil could be eliminated of the flexibility of the overpasses. So it's quite interesting to see, because nobody can measure it, but we can see in Hungary the different type of overpasses doesn't prefer the animals. For example, large ungulates. Only small mammals can use it, but I don't know, I cannot understand why, but not I, but other experts cannot understand. This is well preferred, it must work, but the camera trap said that animals start wandering, and after that one tracks is coming under the overpasses and go back to the forest habitats. I never would like to connect the overpasses. So thank you very much for this presentation, and please protect the license, protect the license.
Thank you.
Roland.
Thank you. So we will finalize the workshop with an overview about the analysis we have done with the data which was generated in fieldwork, and this presentation will be done by Florian Danzinger, who is in Vienna. Hi, Florian.
Yes. Hi from Vienna.
Okay, ready to go.
Yes, thank you, Roland. Thank you, Christoph and Mořic, for your introduction and details on the functional monitoring. I now would like to give you some information on the analysis and the interpretation of the first results. And of course, we're also interested in inputs that we can obtain by you, what we should do maybe with our data after this workshop. So the monitoring was situated in 2 areas in Austria, in the east of Austria here, and in another area in Upper Austria, where there is currently a discussion where to build a green bridge. Today I would like to show you just the eastern Austrian pilot area, and there we have a bottleneck situation on the Alpine Carpathian corridor. That area is called Bridging, and there we already have 2 green bridges. And Roland already mentioned this. We chose some target species. In our case, this was the large herbivores, red deer and wild boar, because in comparison to Hungary and maybe also Romania, large carnivores aren't really present in our landscapes anymore. So this would not allow us to really give a clear statement on the functionality of our corridors. And also, these large herbivores also serve as umbrella species for all the other species groups. Just to show you how we calculated the corridors in the region, we used different input data sets, be it land cover, digital evaluation models, but also geodata on the river network, on over and underpasses, and of course the roads, buildings, and railway lines in this area. Then we calculated core areas and the large stepping stones there, and a resistance model, as permeability model showed us where the animals that are migrating in the region most likely would go. This is the result on the left-hand side, and if you look at these areas in detail, we have 2 strains or 2 corridors that connect these larger woodland areas. and especially in this left area here, see there is a major highway crossing the bottleneck situation, and 2 expressways here and here, which makes it especially difficult to test this area for migrating animals. But there are 2 green bridges in this area and in this area. I hope you can see my pointer. There was an alternative route that we also tested. These 2 dots are the monitoring devices, the cameras, and in some cases also light sensors and sound sensors, but I will show you now. So Mořic and Roland already told you we mapped, or we monitored in 2 methods, stationary monitoring devices, camera traps, light and sound, and the field mapping methods where Mořic collected different signs of activity or directly observed animals in the field. The camera traps were placed at 26 monitoring sites in this patching area. The monitoring started in December, is still running, and now I would just show you the first results for the process data that was produced until the end of May this year. Of course, the wild cameras record day and night, and in this just few months, Mořic processed 12,252 specific sightings, and I think, of course, a lot more pictures when the cameras just recorded wind or snow or light events in these areas. Yeah, the data includes date and time of the picture taken, the category of activity, be it animal or human activities, and of course the species, the abundance, the exact spot, of course, of the camera, and the direction of movement of animals. So when looking at the details aggregated for all the 26 sites, you can run some very interesting analysis. For example, the activities of humans and animals in the area. So we see a lot of these sites are also visited by humans, which poses, of course, disturbance. Humans are crossing these cameras by car, by foot, using machinery for farming, mostly, having a stroll with their dog, or also, of course, cyclists, motorbikes, horseback riders, and others. Looking at animal species, you can see the roe deer is predominant there, but of course we have a lot of other species there, which is quite interesting. Of course, hare and wild boar, but a lot of bird and carnivores, smaller carnivores in the region were detected. We then tried to group, to aggregate these many species to species groups to represent the habitat requirements of these species, and to have a simpler look at the data that we collected. And so we had these groups of open land species, woodland species, and species that live that uses habitats of woodland and open land to run the further analysis. What is more interesting, that I think helpful for the analysis of the corridors, is, for example, the activity patterns of our animals, but also the humans. And here you can see all the 12,000 data records and the peaks in human activity in the morning, and then again in the afternoon, so maybe the rush hour. And you can see that the animal activity is clearly shifted from this from this pattern, and the animals are avoiding, of course, it's obvious, the human activities in the areas. You can do this for all animal species, of course. Yeah, I think for wildlife ecologists, this would pose also some nice data. And you can do it, of course, for the human activities. There is an interesting peak, for example, of dog walkers right before they go to work at 8 o'clock in the morning, or, for example, the cars that passed the monitoring site. So quite funny, but now we are getting more serious, and I would now like to show you some spatially explicit results. So, of course, all these diagrams could also be produced site-specific. So here you can see, again, the human versus animal activities all over the region for all the sites. The size of the pie chart is related to the total number of activities. So, for example, these two very big pie charts, there the human activity was so high that the pie chart is also covering this much area. But the analysis of these different species groups. Here, this is more interesting. You can clearly see that, of course, woodland species are closer to the big wood complex in the north and in the south, and in between, in the rather featureless landscape, these woodland species, yeah, hardly occur. When looking at the specific sites of the green bridges, here is the southern green bridge near Pötsching. Here you can see three kinds of passing possibilities for migrating animals. There's an underpass here. It's a broad underpass, which is also featured with a small stream in between. In the middle of it, a state-of-the-art, very big and broad green bridge over the motorway. And there is also a small bridge that is just a paved road. And here you can clearly see that animals are avoiding both of the smaller passes, so that the underpass and the overpass. We also saw that both of these passing opportunities had the highest numbers in human activity. So this may be also another point why the animals did not went through these underpasses and overpasses. But of course, the green bridge works totally fine. We have a lot of woodland species there, a lot of open land species, and some of these called generalist species. And when we look at the northern green bridge in Mühlendorf, which is a green bridge situated in the open landscape, compared to the one I just showed you, there are also again three possibilities to migrate, to potentially migrate. Here is a road underpass, and we have this big green bridge again, the small underpass here. Here you can see that the open land species are dominant on the bridge. There are some woodland species near the wood and this quarry in the north, as you can see here. And yeah, the conclusion here is that woodland species clearly avoid this green bridge. There is one photo trap that had some of these woodland species. But when we really look into detail and into the detail of species, this picture is supported. Here is the analysis of the species roe deer, wild boar, and red deer. Again, you can see roe deer is dominant in both of the corridors. Also, this alternative corridor is dominated by roe deer, and wild boar is also more attached to the woody areas than, of course, the open land is nothing new. But again, when looking into detail, you can see this rather smaller underpass, and the bridge here is hardly used. If it's used, it's just from large animals, just by roe deer, and there was no evidence of wild boar or red deer using these areas. But again, the green bridge that is very well connected within this woodland is used by all three of these species. When looking at the other green bridge in the north, here you can clearly see red deer occurred in 2 records, I think, in this area up in the north, but otherwise we had some wild boar in this patch of woodland. No evidence of wild boar or red deer on the green bridge itself, only roe deer. And if I just want to show you some more of these really nice photos of the camera traps. When just looking at our 2 favorite target species, wild boar and red deer, yeah, I think it becomes obvious that the red deer isn't really using the corridor. They're using the bridge in the south, the bridge within the woodland, but they are hardly using or are not using the bridge in the open field. As here you can see it in detail, and here there is no evidence of wild boar and red deer using this green bridge. So I think it showed the green bridges are great. They are used by a lot of animals, but the surrounding landscape isn't that great, especially at this site. So I think one conclusion could be that you also need some kind of infrastructure that is leading to the green bridge to support the migrating animals. Another aspect of analysis was the analysis of the field mapping data. So the direct species observation, the tracks and the activity signs that Mořic collected throughout the area. For example, a muddy pool used by wild boar, or the hoof track of red deer, as you can see here. And we produced heat maps to highlight the hotspots of species activity. You can do that for all species combined. So here are definitely no human tracks or activities included. So it's really just animal activities. But you can also do it, for example, for our 3 groups, the open land species that are present throughout the corridor, woodland species that are attached to these woodland patches, and the general species that are also present in the area. Here you can see feces, or the home of a fox. Yes, I hope I could show you some things that one could do with all these data, and the data set is really nice. So it was really a pleasure. Thank you, Mořic, for producing such a nice data set. But now I would also like to discuss with you what other types of analysis would be useful using this huge data set. We also have this data set for the other case study area. So there is a lot to do and a lot of data to work with. This would maybe be a question. Maybe I just tell you all the questions, and then Roland and Christoph and Mořic could moderate some kind of discussion. Maybe there are another ideas for the interpretation of these results I just showed you so far. These are preliminary results, just to add again. And because roe deer was so dominant in all the monitoring sites, could roe deer also serve as an indicator species for the functionality of a corridor? And last but not least, how could we improve the monitoring method? Do you have any ideas? So thank you so far, and I hope you will have a good discussion there. Of course, I will be listening. Thank you.
So thank you, Florian, for this great presentation. And yeah, I give the floor to you. Do you have some questions to Florian? And then maybe we have a short discussion about the questions Florian raised up. Yeah, for me, essential question is the roe deer question. Could we use the roe deer to do this analysis, or to make to answer the question, is the corridor functional? Because the roe deer is an open land species, it does not need really these corridor structures, but I think it also gives us an idea that the landscape is permeable. But that's the question. Can we use the roe deer for the evaluation of the functionality of our corridors in this area, but also in the Kobernaswald area and also in the areas in the other pilot regions? So I hope some wildlife ecologists are on board, and yeah.
Roe deer and the wild boar, you cannot adapt it to this model because both species are adapted well to urbanized habitats, and for example, roe deer can be prefer well the different agriculture, croplands and so on. The red deer, red deer could be it's well adapted because it's drive the forest habitats and the alleys, because it's not open field animals in the Maytime or in the breeding area. You can hear it, and it protected the different areas of the male individuals. But the red deer is a target species in my view.
Yeah, I have the same opinion. Okay. Yeah.
Thank you. It was very nice to hear your presentation. I was wondering that using your data set that you have, could you propose what is the minimal distance between those forest patches to preserve the connectivity of the landscape for wild boar and red deer?
I think that would be an analysis that we easily run. We didn't do it so far for this data, and Roland and Mořic already mentioned that we had some problems for the sites, for the installation of camera traps on some crucial areas on this corridor. So there were some some woodland patches that we would have loved to monitor, but the landowners didn't allow. So there are some holes in our chain of monitoring sites. So yeah, that would be a nice approach to really also cover the distances in between the woodland patches that animals have to pass. Thank you.
I have only one question, Florian, to you. We talk about the Slovakian colleagues that have you got monitoring data? It was quite interesting to see that the human activity in the wildlife mitigation measures as animals. But have you got data sets before and under the COVID phase? Because it could be interesting to see that in the closing process, which was in Austria and to us in Hungary and other countries, that people need to use the human-made landscape in the flat, not in the nature. The animals could be adapted because we Hungary see that after the traffic was lower, the traffic mortality, the roadkill number was higher in normal daytime, not in the nighttime, because the animals go back to the natures, so the nature and the road too. So it's quite interesting that if you have data sets from before, after, or under the COVID closing phase, it could be interesting to see that animal activities were changing the wildlife mitigation measures. Thank you.
Thank you for your question. Unfortunately, as far as I know, not, because we started in December last year with this monitoring method. But I also heard a lot of from a lot of studies that also underline this effect. But also again, some other effects like that people got more active and maybe also disturbed in some places, natural places and in semi-natural places, that the disturbance was higher than before the COVID phase, because people tried to go out to hike, to ride their bikes, and yeah, that would be really an interesting aspect in that sense.
Yeah, thank you. I would like to mention and to comment also the question raised about roe deer and wild boar, and the species we have chosen as the model ones, and I think it very much depends on the general situation in each territory, because in Austria the roe deer or even the red deer population is much higher. It has its reasons. In Bulgaria is we have in the remote areas the roe deer population is pretty good, in a pretty good condition, but in our pilot area it's completely different. And at the same time the wild boar in the model area, according to the hunters, according to our observation, in the adjacent areas, few hundred meters from the motorway passing through, is in a good situation, but we haven't found signs of them passing, and this is really then to the issue how we define the ecological corridor. The ecological corridor, if it's for forest species and if it's for bears and wolves, this is something. But if it's if we're generally talking about the permeability of and transparency of the motorway, for example, this is a completely different story, because the motorway in our case is creating or is part of a different type of habitats, which is very suitable for shackles, golden shackle, for example, which find this area very suitable for it. And then golden shackle is not good for our case if we are defining the ecological corridor for the brown bear and for the wolf in terms of more forest available in general in the area. And that's yeah, we should think more and more deeply into that. We were very happy to have the shackle as part of the large carnivores, but we are entering into a completely different picture from what our initial wishes were defined. And yeah, that's just.
Just some final word from my side. So we have some of these sensor boxes with us. We are happy to give them out, to borrow them to you if you have some sites where you could think these measurements would be interesting. The batteries are fully charged, so you have at least 2 months of period of data recording. Yeah, so if you're interested, just let us know.
But then you have to participate at our final workshop in Vienna, at the SaveGREEN workshop, to bring back these boxes to Vienna. But it's a great time because we have the Christmas market there, and so it makes sense to come to Vienna, not only for the workshop. Yeah. Yeah.
They won't change their owners.
So, okay, I think we are in the overtime, but if there are some questions or discussion left, I think we have 5 minutes more. Otherwise,
can I ask by Zoom?
It was, I think, a long day, yeah, and I think, yeah.
Roland, just one more question here online on Zoom.
Yeah, I have a question,
okay.
if it's
Yes,
okay.
please.
Hi, thank you for your presentation, Florian. Really interesting. I was wondering, maybe I didn't catch it. How did you use exactly the system that was presented before, the whole application in your data collection, and did it make it more effective in some way?
So to clarify, I just collected, I think, 10 data sets when I visited one of the green bridges, but most of the work, or all of the work, was done, of course, by Mořic. And he described that, yeah, of course, this application, you have to get used to it. But I think maybe, Mořic, you can add some more to this, because you did this in the field. I think it's quite handy. So maybe we can hear Mořic again.
Yeah, can you repeat your question, please?
I'm asking how, when you use the system, the application for to collect the data for this research, how was it more effective? In what way did you feel that it made the work maybe better than the regular methods?
Yeah, so basically, I think the camera camera monitoring was much more effective because we received a really nice data set. I think basically around more than 12,000 pictures. And from a wildlife point of view, yeah, we can easily determine the species. But comparing, for example, the tracking, that was much more harder because yeah, I had to go through all biocorridors, but the conditions in a real life, it's not so good when you are in the field sometimes. And this you have to also consider. Yeah, so according to my point of view, I think the camera trapping is much more better.
Okay. I also have a question, Mořic.
Oh, camera trapping, camera monitoring, sorry.
Mořic, did you use any software to in the processing to select the photos where maybe just the wind moved them, the grass or something like that?
Yeah,
I think there were 12,000 pictures with animals on them, and maybe, I don't know, 50,000 in total.
Yeah, I don't remember the exact number which in total records was catched in the field, but I think at least five times more or 8 times more. It depends on the localities. And what we can see right now, this is the really minimum, but this is the real data of the human and animal activity. And I used, there are many softwares, but I used, I think, software which called PhotoPro or something like that. And basically I sorted the data which have no information, and this data was deleted. And the data which obtains some information about the human activity and the animal activity, that was transferred to the CSV format and then afterwards to Excel. And right now it's available to some further analysis.
I'm not sure if I understood the initial question right, so maybe I'll just barge in. I'm saying something that's completely irrelevant, but my understanding of your question was, to what extent did the novel approach that Roland described in the beginning change, or why is it better than other approaches that you use elsewhere? And I think our idea, or Roland's, Uber's idea, was that the output is a standardized output that can be, so we have 8 pilot areas across the whole project. If you use the QField app and the steps that were described by Roland at the beginning, it creates a standardized data model that can then, or standardized data that can subsequently, for the later processing, makes everything a lot easier to update, to upload into the map to create the standardized, or the analyzed maps that Florian now showed us, and also to upload into the online system. So that's why, that's sort of the benefit to using that, the QField app, etc. Does that make sense?
Yes, yeah, that's what I meant, because the data gathering seems to be the same as usual.
Right, with a few sort of standardized categories, but maybe Roland's the better place to respond to that. But I think that's where the real benefit in the system is.
I think this standardized model is nice because we generate comparable data sets across the pilot areas. And as you mentioned, it's more and more important to have this cross-border aspect. So if we generate data in Austria and Hungary, they must be comparable. And if we have a standardized data model, they are comparable, they can be combined very easy. And that's the main benefit of this harmonized data model. And it would be great if we can agree, okay, we want to use this model also in future projects.
Thank you.
So I think we are on the end of the session. Thank you all. We would be happy to greet you tomorrow at our table so we can show you how this box is really working and also how you can access the data sets which we are generating in the SaveGREEN project. And I hope these data sets will be used in other studies, PhD programs for students and scientific work, because there's a lot of information inside the data sets, and we have only to December to do this analysis, and it's too short. So I hope you will use also this data set for your future work, and we welcome you tomorrow at our table. Before it's in the red room or blue, the blue session room. So thanks.